Hello, everyone. Welcome to our WAPP Research Seminar Series, Fairness and Meritocracy at Work. My name is Iris Bohnet, and I serve as the co-director of the Women in Public Policy program and am a professor here at the Kennedy School. This semester, the seminar will examine how organizations can build fair and merit-based workplaces. We'll have a number of speakers join us almost every Monday unless there is a holiday or a vacation. Today, we're extremely excited to have Professor Katherine Coffman presenting on choosing and using information in evaluation decisions. And Katie, I have your title here, which is the Piramal Associate Professor of Business Administration, but that doesn't seem right to me anymore because Katie just got tenure last December. And so this is very, very exciting. So we're super happy for you. Congratulations. So before joining HBS, where she is now a tenured professor, Katie was an assistant professor of economics at Ohio State University and previously a doctoral student here at Harvard. In her research, she uses experimental methods to study individual, team, and managerial decision-making with a focus on the role of gender stereotypes in shaping beliefs. Our speaker will present for about 30 to 40 minutes, and then we'll have time for questions from our audience. We ask that you please hold your questions until the end of the talk, unless they are urgent or clarifying questions, then you can just put them into the Q&A and I will read them to Katie. And that's just more generally what you should be doing. You should please type your questions in the Q&A function and I will read it aloud. We do ask that any audience questions be brief, be on topic, and posed in the form of a question if at all possible. Now, with that, we're all super excited to have you, Katie. Thank you for joining us from your sabbatical in Australia, where I know it's incredibly early in the morning. So thank you for being here.
Oh, it's my pleasure. WAPP has always been a special place to me, going back to graduate school and working with Iris. So I am absolutely delighted to be here and be with all of you, and talk a bit about my work on thinking about how we seek out and use information about candidates during things like hiring processes. So with that, I will dive in. So, if you thought about how we sort of classically have studied discrimination in economics and other social science, there's a very common paradigm that we sort of think about, okay, what if we constructed two candidates who had exactly the same sort of resume and experience, and all that varied between them was their gender, right? So maybe we just change a name on a resume. This creates a really nice, clean design for thinking about identifying discrimination. Because if we see that someone like a hiring manager treats a male resume differently than a female resume only because of the name difference, right, that suggests to us, okay, this really is discrimination and not something about, the candidates being different in some other way. Now, so that's a very helpful empirical approach, but we think it kind of misses out on some of the richness that happens in field environments. So studies of that style sort of show that given the same information about candidates, right, a hiring manager or other evaluator may evaluate a man and a woman differently. And so we're going to sort of take that as a jumping off point and think about sort of extending it in two ways. So the first is sort of thinking about, well, what if evaluators can actually choose how much information to acquire? So rather than just being presented with information, the way things sort of actually work is people sort of decide, right, how deeply to read into an application packet, whether to reach out and schedule an interview, right? How much to scrutinize a given piece of information from the candidate. And so that creates a slightly different environment, right? And if you just thought about that in the form of that same sort of caricature picture, right, you could imagine a hiring manager considering a male candidate. Maybe they think this is a sort of promising candidate. They read a little bit more and they acquire what we could think of as sort of a negative signal, right? Maybe a more negative recommendation letter or reference, right? Well, what happens then? The hiring manager has this choice, right? Do I make a decision now and decide not to move forward with this candidate, Or instead, do I decide to sort of continue pursuing information, right? So in this case, maybe I read a little bit more deeply. Maybe I call another reference, right? In that case, I can perhaps sort of explain away that negative signal, get even more information, perhaps it's positive, and maybe that even leads to the positive outcome of being hired, right? You could imagine contrasting that, right, with another candidate, perhaps a woman. You go in with maybe a different prior about that candidate, right? You're not as sure about them. You get that same sort of negative signal, right? A less positive reference. Well, here you might imagine that the discretion about how much information to acquire means the hiring manager, instead of reading a little bit more deeply, decides to stop there, right? And not hire that candidate. And so, through these choices about how much information to acquire, you could end up with sort of that same discriminatory outcome, but it's driven in part by the hiring manager's decisions about how much information to acquire about the different candidates. So, that's what we're going to be trying to look at in sort of a controlled environment. The second question we're going to have in the background is thinking about the role of stereotyping and contributing to these patterns of discrimination. And so what do I mean by that? I think the design hopefully will make it clear, but just, in that same sort of picture form, right, we're going to ask how the evaluator's sort of assessment of a candidate from one group, let's say the man here, depends upon sort of how that man compares to some implicit reference group, in this case, women, right? So we're going to think about sort of the contrast effects of even when I'm trying to identify or evaluate a candidate in isolation, right? How does sort of the comparison I have in mind in the back of my head, sort of that contrast between two groups, shape my decision making? And again, hopefully that when I get into the details of the design, which I will in just a minute, that's going to become a little bit sharper. Okay, so I'm just going to briefly mention, obviously, we're building on a very large body of existing work on discrimination and discrimination in particular driven by beliefs, right? And this is the idea that it's perhaps not always prejudice or animus that's driving the discrimination, but instead potentially inaccurate beliefs about the performance or talents of certain candidates based upon their, let's say in this case, gender. And there's also, in the last few years, been this emerging body of work starting to think about these questions about acquisition of information, right? What happens when we sort of endogenize the ability of evaluators to seek out different types of information, paired with sort of thinking about biased responses to new information, right? So even conditional on getting information, how do I update my beliefs based upon the information I get? And we're hoping to sort of look at each of these pieces in one unified controlled setting where we can think about, okay, what's the cumulative impact of these forces on evaluation decisions? All right, so with that, let me jump into the experimental design so I could be really concrete here. So this is going to be an experiment we run with a large sample of individuals online. I'll walk you through the details, give a bit of logistics, and then get to results. So this study is going to take place in a simulated labor market. What I mean by that is we're sort of taking regular people and placing them into sort of a hiring paradigm, right? We're going to have some people come in and serve as our evaluators, right? And their job is going to be to think about assessing the performance of other real people who we're going to call candidates. So in what you can think of as sort of a pre-study, we're going to recruit these candidates to perform a task. In our case, it's going to be a short math and science test. We're going to look at the performance of candidates, and we're just going to split it down the middle. Anyone who is above median, we're going to call their performance above the bar. Anyone who is below median, we're going to call their performance below the bar. Okay, this is going to make our lives much simpler, both in terms of how we explain things to participants, how I show you the results, right? We're going to take rich performance information and collapse it all down into just two types, right? There's above the bar candidates and below the bar candidates. And from the evaluator's perspective, their whole job is going to be to decide whether a candidate they're evaluating had above the bar performance or below the bar. And their payment is going to depend just upon correct classification of the candidate. So, what do they actually know about the candidate when they're trying to make this assessment? Well, as a basic, they are going to see a simple resume for the candidate in a standardized format, right? Where it describes the candidate's sex, male or female. It's going to describe their answers to four other very basic binary questions. Okay, so we ask candidates some simple questions. Do you prefer beach or mountain vacations, the spring season or the fall season? This information, you should think of it as sort of hiding in the background of this study. What it allows us to do is differentiate candidates. So when we show an evaluator a male candidate, we don't just show them the same male candidate over and over. These are actually candidates that vary along these other dimensions as well, and also provide some plausible deniability or ability for evaluators to justify to themselves giving different evaluations to different candidates. Okay, so they see this basic resume, and again, their goal here is to decide whether the candidate is above the bar. We're going to give them a big bonus payment, $7, which is a lot in this setting, if they correctly classify the candidate's type, and only 50 cents if not. Okay, but this resume isn't very much to go on, right? So they have the option of acquiring additional information about these candidates. Okay. So after they see that initial profile, right, they're going to indicate how likely they think it is that the candidate is above the bar or not, right? So they do this with a simple slider scale, and we're going to use incentives here to get them to hopefully tell us their true best guess. Okay, so they tell us, I think there's a 60% chance this person is above the bar. At that point, and this is, I think, really the critical piece of how our design is going to build in that richness from the field of thinking about endogenous information acquisition, right? They have a choice of whether they're already ready to make their final evaluation, or if instead they'd like to get more information about the candidate. So that's the choice they're going to have. If they choose to get more information, right, they know that they're going to receive signals about the candidate. So again, because we want to have sort of the control to be able to sort of cleanly say how are evaluators treating male versus female candidates, all else equal, right? We're going to make sure these sort of signals that they acquire are sort of standardized in a way that's easy for us to interpret and easy to explain to them. So the signals are going to be binary, right? If you get a signal, it's going to be either positive or negative. And evaluators are going to know that the type of signal you get, positive or negative, depends upon what you can think of as the true state or the candidate's actual type, whether they were above the bar, right? So an above the bar candidate is going to generate positive signals 3/4 of the time. Okay? On the other hand, a below the bar candidate is only going to generate positive signals 1/4 of the time. So in this way, signals are quite informative, right? They're not perfect. If you see a positive signal, it could still be a below the bar candidate. But, from a Bayesian perspective or even just an intuitive perspective, they're giving you a pretty helpful piece of information in thinking about what the candidate's type is likely to be. Okay. I have in quotes here that signals are costly to acquire. What is costly? Okay, we're going to make them pay 5 cents for acquiring a signal. Okay, so this is a very small cost. Remember, the benefit to correct classification is $7 relative to 50 cents for incorrect. So that 5 cents cost, even in the context of the study, is a very small cost. So if the evaluator does decide to get a signal, right, we show them the signal, they're going to do a new likelihood slider, right? So we get their updated beliefs. Do they think, is the candidate above the bar? And then this process repeats where they're going to decide, okay, now are you ready to make your final evaluation? Or would you like to acquire another signal? Okay. This is not going to be a study about memory, right? So evaluators are always going to have access on their screen to the full profile of the candidate and all the signals they've received about the candidate. They're going to know how many signals they have left to acquire. So they're going to see all of that. They can get up to 5 signals, one at a time, for each candidate. But after 5, we are going to cap them out and have them make their final evaluation. So that's our sort of main treatment, this endogenous info acquisition treatment. We're going to also have a treatment for comparison purposes that's exactly the same, but we're going to force every evaluator to get all 5 signals about each candidate they see. Okay, we're going to call that our exogenous treatment, where we sort of standardize, right, and enforce acquiring the same amount of information and more information, really, about every candidate they see. Okay, so one treatment variation is that exogenous versus endogenous. The other treatment variation we're going to have in the background is relating to that stereotyping piece that I mentioned up front. So now let me try and make that really concrete. What we're going to do is across evaluator, right? So each evaluator is going to be hiring from a given pool of candidates, right? And the way the pools are constructed is designed to sort of fix evaluator beliefs about gender differences within the pool. Okay, so let me like zoom out and give sort of a perspective on this, right? So in thinking about belief-based discrimination, right, we expect that the sort of person's prior beliefs about what gender differences are in a task are going to matter a lot, right? If you're evaluating people, let's say in a math test, right, and you're an evaluator who tends to think men are a lot better than women at math, let's say, that's going to matter a lot for the decisions you make. And for me as a researcher to understand the role of those prior beliefs in driving your decisions, I'm going to have to, one, sort of elicit those prior beliefs, get you to tell me the truth about what you believe. And then two, ideally what I would like to see is sort of evaluators with a whole range of different prior beliefs make decisions. So I can say, hey, these priors lead to much different decisions than these priors. That's actually pretty hard to do within an experiment, in part because we don't observe that much variation in prior beliefs in a lot of tasks, and it can be hard to get people to tell us the truth about these things. So we're going to take an alternative approach here, and what we're going to do is try and fix priors. Tell people, hey, in the task you're evaluating from, these are indeed the gender differences in the pool that you'll be hiring from. And so what we do here is we have some evaluators, right, evaluate a candidate pool where the male candidate has a 60% chance of being above the bar, but a female candidate has only a 40% chance, right? So that's sort of mimicking a prior of thinking men are more likely to be qualified than women. But to sort of back out what the role of priors is in sort of contributing to any decisions we observe, we're also going to have the flip side of that, right? Some evaluators are going to hire from a candidate pool where it's the female candidate who has a 60% chance of being qualified and the male candidate who has a 40% chance. On top of that, it's going to be helpful to have sort of these other candidate pools, right? The one where everyone in the pool has a 40% chance or everyone in the pool has a 60% chance. So we're going to have those 4 different pool types, and that's going to be really essential for backing out the role of stereotyping or prior beliefs in contributing to the decisions we observe. So an evaluator is going to be randomly assigned to either exogenous or endogenous treatment and to one of these 4 candidate pools. Okay, so all of that is going to happen across subjects. Within the context of the study, they're then going to see 5 candidates drawn at random from the pool that they're assigned to, and they're going to evaluate those candidates one at a time. Right? So in order for those candidate pools, right, in terms of their composition to be helpful to us, the evaluators have to know what the composition of the pool is. And so that's part of what we're trying to do in the instructions for candidates, right? We're going to show them a series of pie charts that for each characteristic shows them the share of candidates in the pool who truthfully are above the bar. So here I'm showing you, okay, the candidates who prefer beach vacations, 41% of those candidates are above the bar. For the candidates that prefer mountain vacations, 39% of them are above the bar. And we're going to do that same thing for every characteristic, including gender. After they see that set of pie charts, we're going to give them a summary table So you can see this table here is the table that someone would see for the 40% treatment, right? Both male and female candidates have a 40% chance of being above the bar, right? But it's showing them that plus the percentages for those other types. So in this way, we're trying to give them sort of very detailed information about the candidate pool that they'll be hiring from. This table is also available to them throughout the study, so they can always click on that and see this information. And that's how we're trying to really fix prior beliefs across treatment. Okay. You'll notice in this example table, right, we build pools in the design that actually try to minimize differences across these other dimensions, right? So it's always the case, we're relying on the true answers of candidates, so it's not perfect. That's why you see these 39, 41% for some of these, but we are trying to sort of minimize differences in those other dimensions so that we don't end up with people just having a lot of confusion about why mountain vacation candidates are really good at math. Okay, great. And this is the profile, an example of a profile an evaluator would see. You can see that it sees the answer to all 5 questions with a little icon for them, just so that they can see the profile and hopefully digest it easily. All right, so let me say one more note on the design before I get to results. So I mentioned before that signals were costly in that they had to pay 5 cents to acquire each additional signal. One thing we realized in pilot data was that people didn't seem to be acquiring a lot of signals. So in our pilot, we were charging 10 cents per signal. So we said, okay, well, we're going to make them even cheaper. So we'll cut it to 5 cents. But on top of that, perhaps the real cost of signals for these evaluators is actually the time it takes to get the signals. And so what we do is we have this filler task, right? Where for every skipped signal, right? And skipped, I mean, let's say you evaluate a candidate and you decide to get only 1 signal, which means you decided to sort of not get 4. We're going to give you 4 filler tasks that are designed to take the same amount of time, and you're going to have to complete those before you move on to the next candidate. It's a very simple filler task. They're basically dragging a slider to a number, right? You press the click me, it shows you 63. You drag the slider to the number 63. You tell us whether the number is above 50 or below 50, and then you move on. And you can see here in this design, it's sort of trying to parallel what would happen if they got a signal, right? They have to sort of think about positive or negative, they have to update their beliefs, and then they can move forward. So this is basically a time task, and that allows us to say that from a time perspective, signals are free, right? They're not saving any time by not getting signals. So the only cost here, right, seems to be the financial 5 cent cost of getting a signal. All right, a little bit of logistics. We ran this on Prolific, which is this online platform designed to conduct academic research, right? We ran it a couple years ago now. So before, I think we were as worried about sort of AI and large language models taking studies. But even that said, we do a number of things to try and ensure high data quality in the data we collected. It's a large study. We have 3,200 participants, so 400 in each cell. And we're going to pay them for completion. And on top of that, we're going to sort of take 10% of evaluators and pay them incentive payment. Okay, great. So let me just walk you through the sort of empirical approach so we're all on the same page, right? So to identify sort of classic sex discrimination, what we would look at here is, do we see differences in the likelihood that male and female candidates are rated or classified as above the bar, right? So visually, we'd be comparing the candidates in blue to the candidates in red. You'll see that it's perfectly balanced in the sense that, they have the same share of candidates with 40 priors and 60 priors. So we can just sort of do that and look at whether we see discrimination on the basis of sex. Okay. The stereotyping piece is going to be a little bit more subtle. So I just want to make sure we understand, right? Do we see discrimination on the basis of stereotyping, right? Or reliance on sort of group differences and priors? What we're going to do here is ask whether the evaluation of a candidate depends upon sort of their group's relative advantage in the pool. Okay, so what does that mean? we're going to ask whether candidates who have a 60% chance of being above the bar actually are treated more favorably when the other group in their pool has a 40% chance compared to when the other group in the pool also has a 60% chance. So visually, that's comparing sort of how the candidates in blue here, the advantaged candidates, are treated relative to the green candidates who are sort of equal within their pool. Now, just from a simple statistical perspective, the candidates in blue and green here are exactly the same. They have a 60% chance of being qualified, and in the evaluation task, that is all that matters. You have a baseline probability of the candidate being above the bar, and then you're going to see in expectation the same series of signals about those candidates. So if we see that the advantaged candidates, the ones that are 60-40 compared to 60-60, are actually treated differently, that is like smoking gun evidence that evaluators are doing something, irrational in a sense, and using group differences in the background, right? That contrast that, sure, it's 60, but they're a lot better than the other group, right? That's biasing their decisions in some way, and we're going to be able to back that out through this design. And the reason we think that's helpful, right? If you thought about this, how does the evaluation of this target candidate depend upon whether he's being compared within a pool implicitly to a female candidate who has a 40% chance of being above the bar compared to a 60% chance of being above the bar, is we think that's going to be helpful in thinking about, the role of sort of gender gaps in driving discrimination in the real world, right? So, okay, let me show you our results, right? Overall, we actually see no discrimination on the basis of like sex, just simply, okay? So let me show you that, right? If you thought about initial likelihood assessments, right? So this is you see a candidate, what do you think the chances are that they're above the bar? The truth here is 50%, that's that dashed line. It is a mystery to us why people seem to be optimistic in this study, but they are equally optimistic for men and women here. What we see is no difference in people's initial likelihood assessments about female and male candidates, right? They seem to think they have a similar likelihood of being above the bar. That seems to be true reassuringly in both the endogenous and exogenous treatment. Again, this is initial likelihood before they've seen any signals, so these two treatments are the same at this point, right? Once we get to final evaluations, so now evaluators in the endogenous treatment have had the option, right, to acquire signals about candidates. We see still no differences for male and female candidates here. They still remain optimistic. In the exogenous treatment, right, we forced people to get signals. It seems like that additional information, perhaps not surprisingly, has brought them closer to the truth, right? So we see similar final evaluations for male and female candidates and right around sort of on average being correct. Okay, but overall, what I want you to see here is that once we fix prior beliefs and we tell you the chance of a male candidate and a female candidate being above the bar, we do not seem to see any discrimination purely on the basis of sex, with female candidates being treated differently than male candidates.
Katie, can I
Yeah,
ask a quick
Iris.
question of clarification? And that is in the endogenous treatment. Are we also comparing five endogenous pieces of information with the exogenous treatment where it's always five pieces of information? Or is the endogenous group sometimes having fewer pieces of information?
Yeah, so great question. In these sort of summary figures here, I am putting in this figure every evaluator for every candidate, no matter how many signals they got. So this is lumping in, and I'll show you information acquisition in a minute, people who got 0 or 1 signals about a candidate with people who chose to get all 5. And so when you think about differences between endogenous and exogenous, um, they're going to be driven by exactly what you're observing, which is the fact that the people in the endogenous treatment are not getting nearly as much information as the exogenous treatment on average. Great. Okay, so we do see evidence of stereotyping. And so let me show you those results. So these are initial likelihoods, right? And what I'm showing you here is that evaluators' initial assessments of candidates depend not just on the candidate prior, right? The likelihood that that candidate is above the bar, but in fact depend upon these sort of comparisons within the pool. So here's the easiest way of seeing this, right? If we thought about candidates with a prior of 40%, right? Everyone who had a 40% chance of being above the bar, they are viewed significantly less favorably when they're at a relative disadvantage in their group, right? When they're 40 and the other group is 60, compared to when everyone in the group is 40. And that's that green bar, right? So the 40 in the equal groups seems to be treated more favorably than the 40 in the contrasting groups, right? In the same way, the candidate with a prior of 60%, right, is viewed significantly more favorably when they're at a relative advantage within their pool, right? When they're 60 and the other group is 40, compared to when everyone is a 60. Now, again, all that should matter is the candidate's own prior of being above the bar. And what we're seeing is that seems to be distorted a bit by how that candidate's group compares to the other group. Okay, so that's initial likelihood assessments. We can also think about final evaluations, right? So now we're looking at what was the final classification of candidates. We see in the endogenous treatment, we still are getting that gap for candidates from contrasting pools compared to candidates from equal pools. So just as we saw in initial assessments, right, the candidates with a 40% chance of being above the bar are more likely to be classified as above the bar when they're in the equal groups than when they're the 40 and the other group is the 60. Similarly, right, the candidates with the 60% chance of being above the bar are more likely to be treated or classified as above the bar when they're 60 and the other group is 40 compared to when everyone is 60. Now, that's the pattern in the endogenous treatment. What we see in the exogenous treatment is those gaps are really going away, right? When we're forcing people to get 5 signals about every candidate, the bias that was there initially seems to be disciplined away by the time they've seen all the information about the candidate, right? So what we make of this, our interpretation, right, is that when we allow for endogenous information acquisition, when we allow evaluators to choose how much information to get about different candidates, that seems to sort of maintain those biases, that stereotyping through final evaluations in a way that would have been overcome through sort of more individual level information acquisition had they been forced to acquire. Right, so let me talk just a bit about mechanisms. I think Iris's question sort of alluded to this as well, right? So when we see sort of this pattern, differences across endogenous and exogenous, right? The question is, well, how much of this is coming from evaluators in the endogenous treatment acquiring less information? Right? And it turns out a lot. Okay, so let me show you this. So the first panel here, observed, is showing you the proportion of evaluators with candidates that acquired that number of signals. So what that is telling you is that in 25% of cases, evaluators are choosing to not get any individual level signals about a candidate. Right? Even once they get a signal, you see a pretty good spread here with a chunk of people getting 1, 2, 3, all the way up to 5, right? So they are leaving a lot of information on the table. All right, so this is a choose your own adventure in terms of how you formalize that, right? When I say they seem to be under acquiring information, you can sort of make that sharper in a few different ways. So one way you could make it sharper is to think about relative to sort of a Bayesian in this study, if they were evaluating the cost and benefit. Well, a Bayesian should basically always get 3 signals or more. We're seeing they're under acquiring relative to what a Bayesian would do. You can also just do the calculation of Okay, in expectation, how much is an additional signal worth in terms of increase in expected payoff, right? Another signal is usually worth quite a bit. In half of cases, another signal is worth more than 50 cents in expectation, which is 10 times the cost of the additional signal. We can also just look sort of empirically and see that endogenous evaluators in our study, the evaluators in that treatment, make significantly less money than evaluators in the exogenous treatment, right? They're much less likely to make correct classification. Okay, so they don't seem to be getting as much information as they should. They seem to be too reliant on their priors, and their priors are biased by these group comparisons. So I think that the key question is going to be to the extent that people stop acquiring information, right? When or how do they decide to stop acquiring information, right? And so you could think about the question of like, how much information or how many signals does it take for an evaluator to decide that they're ready to make their classification? Okay, so I'll show you this in pieces to make it a little bit simpler to process. So let's think first about an evaluator deciding, hey, I'm ready to stop and classify this person as above the bar, right? We could think about for high prior candidates, so those candidates with a 60% chance of being above the bar, right? Are advantaged candidates 60-40 quicker to be classified as above the bar, right? Require less evidence, fewer signals, compared to advantage candidates being slower to be classified as below the bar, right? So when I'm advantaged, it takes a lot of signals, a lot of information before an evaluator is willing to sort of change their mind and think I'm below the bar. Okay, let me show you those results. Okay, so this first panel, right, looks only at high prior candidates. These are all candidates who are identical in expectation. They all have a 60% chance of being above the bar. The candidates in blue, right, that blue step function, those are candidates from the 60-60 pools, right, the equal pools. The candidates in red are the candidates from the advantage pools. They're the 60 in a 60-40 group. Right? So consistent with that intuition I was trying to build on the last slide, right? We're seeing that advantage candidates are quicker to be classified as above the bar, right? That shift to the left of the red relative to the blue in that first panel is saying that on average, we need fewer signals to classify an advantage candidate as above the bar compared to candidates from equal groups. The right panel is showing you the flip side of that, which is it takes more signals for me to sort of accept or believe that an advantage candidate is below the bar relative to a candidate from equal groups. Again, all 60% probability of being above the bar. These are identical candidates in expectation. And what we're seeing is those identical candidates are treated differently based upon whether they're from the advantage group relative to the other group in their pool, or if everyone in the pool is on equal footing. Okay, so we see differences in the amount of signals in the stopping rules that evaluators are showing. And that's going to also lead to sort of differences in the likelihood of being classified as above the bar. So those are those numbers at the bottom, right? 67% of advantage candidates ultimately end up being classified as above the bar, and they're classified that way quicker on average or more quickly, right? Compared to only 61% of candidates from those equal or matched pools. Okay. You can also think now about 40% candidates or the low prior candidates. So we see sort of that same type of pattern, right? Where what do you think about a low prior candidate? Well, you think they're probably going to be below the bar. We see that disadvantaged candidates are slower to be classified as above the bar, right? It takes a lot more evidence, more signals to accept or believe that a disadvantaged candidate, a 40 and a 40-60, is actually above the bar compared to when everyone in the pool is 40, right? And on the right panel here, we're showing that disadvantaged candidates right, are more quickly classified as a below the bar, right, accepting the priors compared to those from the equal pools. So in words here, I think what we're seeing is that relative advantage, right, the sort of difference in the pools seems to lower the burden of proof for evaluations that confirm the group stereotype, right? So if I am an advantaged candidate, right, it takes much less proof for an evaluator to think I'm above the bar, right? If I'm a disadvantaged candidate, it takes less proof for an evaluator to think I'm below the bar relative to candidates that are on equal footing within their pools, right? Contrast that with it's going to increase the burden of proof. It's going to take more information, more evidence for evaluations that go against the stereotype. If I'm advantaged, it's harder for an evaluator to sort of see that I'm below the bar. If I'm a disadvantaged, it's going to be harder for the evaluator to see that I'm above the bar, right? And so this is sort of driving those final classification gaps that we see, right, in terms of how many signals evaluators are choosing to get about different types of candidates. Okay, so let me just close with sort of thinking about these implications for accuracy. So what we see and what I mentioned earlier is that when information acquisition is endogenous, evaluators are not classifying people correctly as often, right? They're going to make more mistakes. And the question is, well, what types of mistakes? All right, so these are high prior candidates. So again, all candidates who have a 60% chance of being above the bar. What's the mistake here, right? What do people have a hard time doing? What they have a hard time doing is correctly identifying what you can think of as an untalented candidate from a high prior group, right? The candidate that's actually below the bar, even though they come from the high prior group. What we see here is sort of big gaps between the exogenous and the endogenous treatment. Right? So if we thought about those endogenous bars, I think the way to think about this is that they're not getting enough information to realize that even though that candidate had a prior of 60%, they're actually below the bar. If they chose to get more signals, they would get a fair amount of negative signals and realize the candidate was below the bar, right? So instead, we see sort of a smaller rate of correct classifications because they're leaving information on the table. So that's giving you sort of the difference between endogenous and exogenous. But there's also another factor here, right? So when we compare sort of those equal, everyone's 60% compared to advantaged, right? I'm the 60 and the other group's the 40, we see even more mistakes when we think about advantaged candidates. So altogether, that's going to give you a 25 percentage point gap in the accuracy rate, right? One chunk of that from sort of leaving information on the table, that's exogenous versus endogenous, and another chunk of that from sort of these contrast effects. So relative to a best case scenario, when there's no contrast between groups, and so I can't do the stereotyping thing, right? I can't use group differences, or I don't use group differences in a way that biases my beliefs, right? And I'm forced to get info, right? If I compare that with sort of the endogenous advantaged, that's a 25 percentage point gap in the likelihood of being able to identify that actually, even though that person is from a high prior group, they're actually below the bar, right? The flip side of that, if we thought about low prior groups, what's the hard thing to do there, right? The hard thing to do is correctly identify that even though they're from a lower prior group, right, of 40%, they're actually talented, they're actually above the bar. Again, right? The endogenous, the correct classification rate is lower, right? They're less likely to realize that there's a talented person in that low prior group because they're leaving information on the table. They're not getting signals that would allow them to see that that person is actually good. And that's particularly true when the person is disadvantaged, right? When they're the 40 in a 40-60 group compared to when everyone is 40%, right? And that's going to be a 16 percentage point gap in sort of correct classification rate. Okay, so just wrapping up and eager to get to your questions, right? What we see here is that group differences, this sort of contrast between the two types, the two groups within a candidate pool, has a significant impact on how candidates are viewed. in terms of initial assessments, how much information is acquired, how beliefs are actually updated, and ultimately what final classifications are made. And that seems to interact with endogenous information acquisition, right? When evaluators are allowed to choose how much information to get, they just don't get enough information on average. A result I didn't show you today, but I'd encourage if you're interested to look at the paper, right, is that we see that the people who are most biased in the sense that they're most likely to use sort of group differences in forming their beliefs, they're the least likely to get signals, right? To get individual level information that would allow them to correct their biases, right? And that leads to evaluators sort of being more quick to make classifications that are consistent with stereotypes, right? And it produces, I think, two important patterns of mistakes that I think we see in the world, right? We seem to miss out on talented candidates from disadvantaged groups, right? That's the hard thing to identify. And we over-select weaker candidates from advantaged groups, right? And so I think what our paper seems to suggest is there can be a role for thinking about how we sort of ensure that people get individual level information, right? That would be helpful for sort of overcoming their priors and in particular any biases they may have in their priors. And that could be helpful for sort of slowing down decision making in a way that might produce fewer of these types of mistakes. Okay, so I will leave it there. I'm excited to field questions. Thank you so much for listening.
Thank you so much, Katie, for this very interesting presentation. We do have a first question by Paolo, and I would like to invite everyone to put their questions into the Q&A. So Paolo is interested in the gender of the evaluator. Does that make a difference?
Yeah, it's a really good question. So for all of the results I showed you today, it does not make a difference. So what I will say is in the background, right, you could think about sort of homophily broadly, which is I'm a male evaluator seeing a male candidate versus a female candidate. But even, this is a kind of part of it too, right? You could be, I'm someone who really likes spring compared to fall, and I see a candidate who likes spring relative to fall, right? That we've seen those sort of similarity drive decision making in some other settings. It just doesn't seem to have a huge impact on what we're observing here. So we have done the analysis. The patterns I show you seem to be true for both male evaluators and female evaluators. That doesn't seem to be a driving force in sort of decision making in our setting.
Mm. Let me maybe add a question while other people might still be typing. So first is an action observation. I mean, your research reminds me of the stories. I mean, your research is, very nicely documenting and proving basically that the people from disadvantaged groups are probably right who say, well, I always need to be better. I need to give more information. I need to prove that I am, competitive. And there's a very nice study of university students who during COVID were offered the opportunity to hide their grades. And they find,
Yeah.
and you know it, but I'm just sharing with the audience. And then they find that in particular women in STEM did not want their grades to be hidden because they knew that they needed that additional signal for the labor market. So my first question is that it's probably what you have in mind as well, but please disagree if not.
No, but, so this is a shorter conversation today, but what I showed you today, it misses one piece of the puzzle. So first, let me say, I think that's very consistent with sort of this, there seems to be a higher bar, right, for disadvantaged candidates. And so how do you meet that higher bar? You share more information, as much information as you can. And then the question is like, can you get the evaluators to process that information and really update their beliefs from it. And so that's a piece I didn't talk as much about today, but if you thought about the study, we have 3,200 evaluators evaluating five candidates each, sometimes with up to five signals about each candidate. So we have just like a universe of belief updating data, right? And what we see is also stereotypes shaping some of that belief updating. So I'd say there's a hidden additional penalty there that we've got to think about too, that we kind of glossed over a bit, which is, in the context of the study you shared, right, I choose to sort of, let's say, reveal my grades because I want that additional signal, right? I have to have like more burden of proof, so I need to share something. But the data we have, and I think data from other studies would suggest, even with that, right, the same grade in STEM for a female candidate compared to a male candidate, you're not going to get as much of a positive bump from it, right? There's going to be bias in how those signals are reacted to. And so you've got this sort of, it kind of amplifies the challenge, which is you need more signals, and even with the same number of signals as another candidate, you're not going to get as much bang for your buck out of those signals you have.
Yeah, no, totally get that. So now comes my harder question that I'm grappling with now, and that is kind of the policy implication. And that's, also related to a paper that we wrote about when in 2016, where we were very enthusiastic about these contrast effects, right? Where we
Yeah.
basically could show that comparing can help people calibrate, that not just act on their stereotypes, but now, I mean, you know the paper, but I'm just telling everyone, not just act on their stereotypes that we might, be inclined to do if we just see one candidate at a time. But if we see more than one particular tool, then we can calibrate more easily and maybe focus more on the GPA, for example, than a person's race or gender. Now, of course, we kind of did in some ways, right? What you're doing here, we're making some of these contrasts very visible, although we never specified the stereotype only by gender in that study. But what is the policy conclusion then? Or do you see a world where we can do away with these comparisons, or is it just the world that we live in? Because gender, race, I mean, everything's socioeconomic background, university you attended, everything, right, allows for these comparisons.
Yeah, no, I think that's right? It's going to be hard to get rid of true contrast that exists in the world, right? And so, I mean, I see, and I think a lot of my work is sort of shaped by your worldview too. So I have a similar worldview in that, you know, your study, one of the policy implications, right, the reason we think about sort of side by side is exactly that it allows you to sort of be a bit more objective, right? Which is like I'm comparing like to like, I'm seeing like GPA versus GPA. When I'm confronted with that, it's hard for me to sort of argue, oh, wait, even though this person has a higher GPA, I'm not choosing them. And that's very salient to me. Um, I think that the sort of policy implication here, we can use a lot of those same sort of tenets, which is we want to sort of standardize and make objective as much as we can. And so, I think there's an argument if you took these at face value to say, okay, we're going to decide in advance, right? How much and what information to get about each of the candidates we're considering, right? And so rather than sort of, I look at this for this person, I sort of read a letter of recommendation for this person, but I sort of only look at the abstract of the job market paper for this person, right? It's that sort of differentiation across candidate that I think gives space for this bias, this wiggle room to sort of distort decisions. And so I would sort of think about policies that would standardize information acquisition about each candidate, right? Whether that's standard templates, trying to put all the information in the same format, making sure we have the same type of information about each candidate, and then really thinking about how we're going to look at and use the information we have, right? And so similar to what you suggested, maybe it's even a conversation up front with, not that we need an exact rubric necessarily, but what are we looking for, right? What's the most important piece of information we want to consider? And sort of putting some sort of structure around that to allow for less discretion in choosing what to focus on or what to even acquire about the different candidates.
Hmm. Thank you so much, Katie. We have time for one last question, and that is about the mechanisms here, about the why the most biased people are the least likely to get information. And you talked a bit about that gap, right? To decompose that gap a little bit for us, but you might have to walk us just through that one more time so we better understand of what that it really consists of.
Yeah, yeah, no, it's a great question. So I think two different pieces there. So this bullet point on the conclusion slide, fair to have questions on because I didn't show you that data today. But so what we can look at, right, for in terms of most biased people least likely to get information, what we can do is look at evaluators who don't get any signals about a candidate or who get very few signals about a candidate compared to evaluators who get lots of signals about a candidate. And we can look at those evaluators' initial assessments. So before they got any information, anyways, right, what was their prior about the different candidates? And we see that it's the people, if we look at the people who go on to not get signals, their priors are much more biased than the evaluators who ultimately go on to get signals. So that could be a few different things, and it's a little bit hard for us to say for sure. So this is speculation, right? So one could be that those people are sort of, less numeracy, less probability oriented, right? So when they're thinking about the likelihood of someone being qualified, right, they're more prone to bias in that, right? And maybe that also means that when they think about signals, they are less likely to realize how helpful signals would be, or they're less likely to think they're going to use the signals correctly, and so they don't get them. But again, that's sort of speculation. It could be picking up, and I don't think this is all of it, but it's something we can't rule out entirely, which is that people who have more biased priors are also sort of paying less attention to the study, being less careful. And so they're not getting information also because they're being sort of less careful, right? And so part of it could be that as well. They're just a different type of participant or evaluator, and there's a little bit of noise both in their prior and their decisions. But I think there's, more to be done there in terms of, okay, why do people whose priors are sort of most inaccurate, or at least most driven by sort of this group contrast, why are they also less likely to then get signals and information, that individual level information that would allow them to overcome their bias? Because I think from a policy perspective, that's a helpful thing to have the answer to, right? Because those are, in a sense, if we want to really change outcomes, the people we want to reach the most with a policy intervention.
Thank you so much, for this answer, and to Paulo and Savannah for your excellent questions. We're at the top of the hour, so let me thank Professor Coffman very much for this very insightful presentation. Unfortunately, we can't quite clap. I'm the only one who can. But I know many people will be clapping. This was incredibly informative. And again, I think documenting a phenomenon that some of us have either personally experienced or have seen happen in the world and that many people have written about, but we really haven't had a clean way to understand these processes. So thank you very much for your work. Next week, we will reconvene for the WAPP seminar again at the same hour. We will be joined by Professor Munn from the University of Illinois Urbana-Champaign, and she's going to be talking about merit-based reward systems and gender wage inequality. And with that, thank you all very much for joining us today. And I hope you're looking at some of the Q&A responses that you're getting, Katie. People loved your seminar, and so did I. Thank you very much.
Thank you so much. It was great to be here. Thank you for having me.